So, hi everybody, and welcome to another session of our series Mittelstand meets Open Source, Industry 4.0 Open Source. And as you see, some things are different today. I'm working from home basically, and yeah, therefore my background is a bit unusual. But I already took a photo and can share it for you if you want to discuss some Zoom background, because it's quite hard to get something that messy as the room behind me. But yeah, we will do the webinar today again in English, as we usually do with the more tech-focused webinars. And today surely is pretty tech-focused, I would say. And I'm very happy that I have a guest today with Kevin. Kevin, hi.
Hi.
And we will give an introduction about him in the slides. Okay, so we will do it as usual. So whenever you have questions, just write them in the chat, and we will try to answer them either directly or after the session. Okay, then I will start with the presentation. First, the roadmap. Many of you may know if they already listened to some webinars. We started at the edge and now nearly reached the cloud, already reached the cloud. And today we will talk about Eclipse Vorto, which Kevin will introduce to us in more detail. And Vorto is about the question, what kind of device do I have, or what capabilities does my device have? When I send data to the cloud, for example, to a D2 instance, as we have seen, then a possible consumer of the data may not know what kind of data to expect. So this is something which Vorto solves, giving some semantics and some kind of structure that everybody knows what kind of data do I have to produce, in which format, and how to consume the data. This is basically what we will discuss today. Yeah, I think I skipped my introduction for today. Vorto is a bit similar like Hono last week. I mean, I'm quite active in the Vorto community. I would say we're doing lots of discussions. I played around with it a lot. Yes, we'll see a demonstrator today that Kevin and I did over the course of the last weeks. We're currently preparing a blog post, but I'm not as deeply involved in the project to tell you something on my own. Therefore, I asked Kevin to join us, and Kevin is the current project lead of Eclipse Vorto, so working full-time on Vorto and surely having lots of knowledge about it. Yeah, he is, as the Eclipse Vorto project is maintained mostly by Bosch IO. He is an employee of Bosch IO, and yeah, will probably introduce himself. Kevin, do you want to add something?
Yeah, I'm the project lead of Eclipse Vorto. I've joined the project in fall of last year and been working full-time on that since. Yeah, and I will try to explain to you today how Eclipse Vorto works, what the project consists of, and how you can use it in your real-life application.
Excellent. So I think this is basically now where we change screens. So I stop sharing my screen, and you can start sharing your screen. The presentation that Kevin will show will also be available on our homepage afterwards. So he shares them with all of us. So yeah.
All right. So I hope you can see my screen already.
Yes.
Great. So I have a short agenda. It's just a couple of slides. I'm going to use them just to guide you through the things I want to talk about. So we will start with a short overview over Eclipse Vorto, and then we will go more deeper into the topic of the domain-specific language that we use to describe devices and device types that is called Waterline. Then we will go into the details of the repository that we have for our models. We will shortly take a look at the plugins that are available and how they are working. Then we can take a short excursion to the telemetry payload mapping, which is some related feature to Vorto. And then we can look into some examples. I think we'll probably look into the examples while we go through the slides. I think that's easier. So we can start with the overview. So Vorto is an open source project. Its purpose is semantic modeling of digital twins and their capabilities. And it consists of 4 main components. So the one component I already briefly mentioned is the domain-specific language, that is Waterline, and we will look into how that works later. Then we have the repository, which is a web application that's being used to create, to manage, and to distribute models. There are also a couple of other features included in the repository that we will also look at later. And then we have the plugins, which are used to transform the Vorto models that are written in Waterline into something else, which provides more value depending on your use case. So this could be source code stubs, request templates, or other representations of the model in a different standard or a different format. And finally, there is the telemetry payload mapping, which uses the Vorto model to map the data sent by the device and normalize it into a predefined format, which can then be redirected to the actual application. So you can reuse one interface because only has to interact with one data format. So let's take a look at Waterline, how this actually works. So Waterline has a couple of main components. The entire DSL is written in eCore, so it's based on the Eclipse stack, eCore and Xtext. And when we look into Waterline, we will see that there is one top-level element that you can see on the top right of the diagram, which is the information model. So this is basically a representation of a digital twin and all its capabilities. Then below that, we will have the function block. One information block consists of at least one or multiple function blocks, and the function blocks describe the actual capabilities. So within the function block, there will be properties. So there will be read-only properties of the function block. So those will be called status. Then we have configuration properties, which are read and write properties. Then we can define events within the function block. Those events that are being described are those that are emitted by the device. And finally, we have operations. So those are functions that we can invoke on the actual device. Another construct within Waterline is a data type. So Vorto already comes with a couple of primitive data types like string or integer. But if you have a more complex data type, you can also use this construct to create a kind of an object or enumeration that you can assign to your properties. And finally, we have something called mapping, which is not shown on this diagram here. So while Vorto models are supposed to be platform and implementation independent, so you can reuse them easily, you can create a mapping to add exactly that information to it. So if you have a concrete implementation of something that has some additional properties that are unique to your implementation, you can use a mapping to add your implementation specific data to the actual model. Next up, or maybe we can take a look at one Vorto model now, so you can see what this actually looks like in real life. So I will use this model right here. This is on the public repository that we will look into next. So I will use the model of a fridge here. So this is a specific kind of fridge. It has this name, which is not really relevant. It's just a certain kind of fridge. That's important. This is an information model that we are seeing here. So this is Waterline. What you always need to do is you need to specify the version of Waterline that you're using within your water model. This is 1.0. This is the only version that is currently out in the fields. This is already released 1.0, so this is a fixed version. And then you will see a couple of properties below. So Vorto uses namespaces to group models together. This is called combishg. Then we will have versions of the model. So whenever you want to make a change, you can create a new version, and then the version number changes, so you can always reference stable models that do not change anymore. And then you will see a couple of using statements. I will go more into detail when we go down here. So this is the information model of the specific kind of fridge, and it has multiple function blocks. So one function block here is the door state, another one is the power state. Then we have a freezer and a fridge down here. So as you can already see, you do not see the details of those function blocks in the information models. They are kept in a separate file. And that's why we are having the using statements here. It works pretty similar to the import statements in Java, for example. So we will now jump into the function block of the fridge to see what capabilities a generic fridge has. So same here, we have the name of the function block, which is fridge. We have a namespace, and now below we can see the actual properties of the fridge. So we have a block here which is configuration, as I just mentioned on the slide before, configuration properties. So those in here, those are properties that can be read and written. So read-write access to those properties here. So we have a fridge super mode, we have a target temperature, and we have a temperature unit. So we can read the target temperature unit, but we can also set it. Then we have status properties. Those are read-only. So we have the current temperature and the temperature unit in here. So those ones can only be read. Those are mostly sensor values in most cases. And finally, we have events in this function block. So we have one event here, which is temperature change. So whenever the temperature changes, the fridge can emit this event, and it will contain those properties here, timestamp, the temperature, and all the other properties. And you can also see the primitive data types here that have been used, so Boolean, integer, string. So that's basically how Waterline works. I will jump back into the presentation now. All right, the next topic is the repository. You've already seen it in my browser. So the official repository that we are hosting is under this URL, vorto.eclipse.org. This is a vendor-neutral repository. So it's not a Bosch repository, it's a repository of the Vorto project of the Eclipse Foundation. So it's vendor-neutral, it's not for any specific project. And it's accessible freely from the internet. You can sign up to the repository using your GitHub account, and you can start create your own models on there. But it's also possible to host the repository yourself if you feel like that suits your needs. So we do offer a Docker container, but you can also just check out the source code and build the repository yourself. It's a Spring Boot application, so it's pretty straightforward and pretty easy to get started with. Self-hosting is probably only really required when you have an on-premise solution without access to the internet, because if you have access to the internet, you can already use the official repository, which has the benefit that you can use the models that are already in there. So a repository offers in general a UI that we've just seen and a set of APIs that you can use to interact with the models. Then there's the web editor that I just used to show you the model of the fridge. There is a review and release process for models. So when you create a new model, It will be created in a draft state initially, and it will be set to private. So only you and the members of your namespace can see the model, but not the public. And when you think your model is ready for release, then you can trigger the review process, and a reviewer can review your model and then release it afterwards. When it's released and set to public, that's the next point here. When you release your model, you cannot make changes anymore. So that's when your version becomes a fixed version. And when you want to publish your model to make it accessible from the internet without logging in and without any more access control, then you can set the visibility level to public. This is only available for released models, of course. So only if a model does not change anymore, then you can release it.
Kevin, there already is one question that probably we can just add in here from Lucas, who asked if Vorto is inherited from schema.org for e.g. the fridge, or how are the models developed?
Okay, yeah, that's an interesting question. So the models are developed, it's basically a community effort. So what you can see here when we go into the repository, that there are different namespaces. We see here something from Bosch, but we will also see some other things, some generic things from Eclipse, some tutorial things. So whenever a device manufacturer or some other party that uses devices wants to create a model, they can apply for public namespace, which is a namespace where you can publish your models, and then you can just go ahead and create your own models. So when you have models in your namespace, then you are also responsible for maintaining it. So it's a community effort. Whenever there's the need for somebody to create models, they can apply for a public namespace and then go ahead and manage their own models.
Okay.
Does that answer the question?
We'll probably come back to the question later on, because then you could talk a bit about how this relates to other initiatives.
Mm-hmm. Yeah.
Probably.
Yeah.
Okay, thanks.
Okay. Final 3 features of the repository that I wanted to mention. Those are the import and export of models. So when you look into the repository and take any model, then you can see you have a download button here. You can download it either as a Vorto DSL, which is a file that contains what you see below here, but all the reference models as well. So everything that's used will also be included in the download here, or you can download as a JSON schema file. Next point is the interaction with plugins. I will show it to you on the next slide, how that works. And then we have a Java client, which you can use to access your models and do some interactions. The Java client basically just calls the APIs, but for programming in some Java contexts, it might be easier to use the Java client. Okay, plugins. So as I've said on the start, plugins transform Vorto models into something else mostly. It's source code stubs, request templates, or other representations that could be other standards or other modeling tools. We have a set of official plugins that are already in the public repository, and there are some experimental plugins. So we can take a look into the repository. So what we see here on the right, those are the plugins. So if we choose, for example, the Ditto plugin, then we have the possibility to transform the Vorto model that we have into Ditto representations. So one representation would be JSON schema, which creates a JSON schema file that can validate payload that is being sent to Ditto. And the Ditto thing JSON would be the representation of a digital twin in Ditto, following the structure that's being defined here in the Vorto model. And with the same logic, we have a couple of other plugins that can be used to generate other things. Hono, for instance, you can generate source code stubs that can be used to connect your device to Hono. So when you click Java and generate, then you will get a Java application that you can run to connect your device to Hono. And leverage the properties that are defined here within your Vorto model. So we have an overview here of all of the main features of the different generators and the different plugins. I'm not going to go through all of them. You can look them up later or try it out if you are interested in that. One thing I can mention is that there's currently in development a Web of Things plugin, which will convert a Vorto model into Web of Things thing description, which is pretty similar to, or has pretty similar use cases as Vorto model, but it's a different standard. And we have a couple of experimental plugins. They are in GitHub. I can maybe go later onto the GitHub repository and show you the current experimental plugins. One of them, which is, I think, the most used one of the experimental ones, is the Azure IoT. That one converts a Vorto model into a DTDL, which is the Azure standard for defining device types. All right, so the payload mapping engine is the next component. It's a standalone component, so the payload mapping engine is independent from the repository. It can load mapping specifications by connecting to a Vorto repository and loading those, but you can also introduce the mapping specifications manually. And then it receives telemetry data and maps it to the predefined format that is being defined in the mapping specification. Currently, we support input format as inputs formats JSON and CVS. And output formats are either Vorto canonical JSON, which is a pretty plain JSON that just has the defined Vorto properties and the value that is being received, and Ditto JSON and AWS Kinesis. So you can directly use the payload mapping engine to normalize your device payload to send it to Ditto, for instance. The protocol that's being used for both input and output is AMQP. And the whole mapping engine is developed as a plugin architecture, so you can add new formats and protocols whenever you need it. You can implement it pretty easily by just plugging in a new implementation for a format or protocol. So I've collected some links here, how to find us. We are, of course, on GitHub. I can quickly go to the repository now. So this is our GitHub page here. You will find a lot of documentation and some tutorials on here. So if you are interested in knowing more about Vorto, I think this would be the perfect place to start for you. So you will find here a Getting Started page that contains a couple of examples and gives you a step-by-step tour on how to connect your devices using your Vorto models. And then there are some examples here, pre-generated dashboard, and some information on how to get in contact with us. And if you're interested in contributing, you will find also the necessary information here.
Kevin, there is another question from Kai, who asks if binary would be a reasonable import for the mapping engine.
Yes, I think so. Since most IoT devices use some kind of binary format, I think this would be a useful addition. I think when there's a specific use case, then we can look into how we can develop that and add that to the payload mapping engine.
Okay, thanks.
All right, and what you also find here is the Waterline 1.0 specification. So if you're new to Vorto and you don't know how to write your Vorto model using the DSL, this is the place for you to start. It gives you an introduction, and then it will go into detail into all the different elements of the language, and it will guide you hopefully towards creating your own model. All right, so if you have questions or if you want to get in contact with us, you can use our GitHub channel. I think we are pretty active on there, so whenever you post something on there, you definitely will get an answer, and also in a timely fashion, I think. Julian, you're also quite active on there, so I think this goes pretty well. And if you want to know more about the Eclipse project setting, then you can go to our Eclipse project page, which is linked here. All right. Yeah, this was just some backup links. I think this is it for my presentation. So, Julian, I think we can go into our demo.
Okay. Are there other questions regarding the general your Vorto concept before we move on to the example? It is, I mean, to be honest, it took me quite some time to understand what Vorto exactly is. Is it really in its core is more of a framework than a language, because with all those plugins, it really tries to bring together the different representations that might be there from, for example, things live or other initiatives. Here's another question from Mehedi, who asks what the difference is between an event and an operation in Vorto.
Mm-hmm. So an event is something that is being emitted by the device. So for instance, if we go back to the fridge, the temperature changed event, if for some reason the door is being opened and the temperature rises, the temperature is changed, and then an event is emitted by the device and sent to whatever application is behind there. An operation, on the other hand, is something that is being invoked on the device. So if you want to tell the device, change your temperature, then this would be an operation that you would call. So those are the two directions. So event is from device to your application, operation is from your application to your device.
Okay, thanks. So I will share my screen. And as said initially, this is something I did not do on my own. In fact, Kevin and I work on that since several weeks by chatting from time to time, and now just took the time to finish this example. And it is quite complex compared to the other examples. So the name Quick Start is a bit optimistic. So if you're really interested in what's happening here, I think you need to take some time to sit down and have a look at what's happening here. The general setup is we have 3 projects involved here. Just to clarify things a bit, we have, of course, Eclipse Vorto, which we want to show here. But we also have Eclipse Ditto here, which will be the target where we send data that we will fetch. And we have PLC4X here, which is the gateway in our scenario. So we are here back in an classical industrial IoT scenario, as we usually have them here in this series. And the setup is, from an overview perspective, the setup you see here. So basically the idea is we have a machinery somewhere in a plant, probably with PLCs, as we had in the other examples. But here, the fact that's different here is that we focus here on the representation. So in the last example, we just took some data out of device to the devices, or probably sent it to Ditto, but without semantics. So without saying, okay, this here is a temperature value, and it's a decimal value, and this here is a Boolean value or something. And this is what Vorto brings in here. So the idea is that for example, the machine manufacturer puts on his Vorto model to the repository, which says, okay, this is a machine which has those 4 or 5 properties, like temperature and a position and a speed and something. And if we would make it in more detail, and also with events and operations and stuff. So this is something that, which would be generally true for all machines of that type. But then there may be some specifics. For example, because for one machine, the drive is electric, and for the other machine, it's hydraulic. So there are, although generally they both have speed and they both have a position, in fact, for both instances of the machines, they have to be read differently or calculated differently because they are different. And this is what a Vorto mapping brings in. So in more detail, you see, it gets more and more complicated. So in fact, what we will do in the Vorto layer is we have one model which we will show. It's in a public repository, totally public, which describes generally what the machine has as capabilities or as properties. And then we have a mapping which is specific to one machine instance, ideally to all machine instances, but this mapping just gives additional information on, I would say, how to retrieve or how to read these properties. So in our situation, the mapping contains the information about where to find the values in the PSC. And then the last thing we have is we already use one, we will use one plugin from Vorto. Kevin, correct me if I'm wrong, but we use one plugin as we want Vorto to generate us the detail representation of this described machine. And this information will then be used in our gateway. This is the code we will show, is the gateway, a small file which retrieves the model, the detail representation, and most importantly, the mapping, then has all information to start to read from a PSC via PSC4X and send the data to Dito. This is all that's happening here. And it may seem overkill for this situation, but imagine now that someone wants to start work with the data, write applications based on the data, so he will rely on the model because the model says which properties are there. And if now someone installs a version of the machine or other version of the machine where things are done slightly different, then you probably need another mapping because it has other PLC programming, so other parameters in it, but the model itself is the same. And you just point the gateway to another mapping and say, okay, now still do your thing. So this is the overall setup. And if you are confused, then just ask questions, and we hope that we can answer it, or probably you need to rethink it a bit. I really, it took me like 2, 3, 4 weeks to think about what Vorto exactly does and yeah, which information belongs where. So with this being said, we will now do the dive into the code and the model. So let me first off open the Vorto repository to show you the model. It is in the public Vorto repository, so you should be able to find it also from your PC. It is, the models are public. Let's see. So I will change the window now. So now you should see my browser pointing at the Vorto repository. I will log in for a second. Okay, the namespace is org-apache.example.plc4x, I think.
No, actually you have to prefix the search with namespace : then you can enter org-apache and then asterisk. Yeah,
excellent. It works. So what we see here is the virtual machine. This is the model for the machine. And if we go in here, we see, I hope everybody sees it. If we go in here, we see this is the description of some properties of our machine. So it has a position, it has a random value, it has a motor current, process state, availability. It is through the whole course of to all the webinar series, we use the same virtual machine programmed on our PLC in Kirchheim unter Tech in the basement. So this is just an example of the machine and what the machine can. And you see we're also giving types here. Because, for example, in Ditto, a property is just a JSON value, so there is no typing in it. But here we can add typing. So this is enough to consume the data and to work with the data, this model, as I know what to expect. But this is, of course, not enough for our gateway to start reading those values. This is where the mapping comes in. And the mapping is called Demo SPS Pragmatics, as it really is the demo PLC from Pragmatics in the basement. So we'll have a look here. And this here, this is, I'll just click here for a second. This here is the mapping we have, and here we give each configuration property from the model, which had position and random and motor current and so on. And here we give it additional attributes, the URL, which is the identifier of the PLC. We give it a rate at which we want it to be read from the PLC, and we give it an address. And this here is basically PLC4X related information. If we would work on another gateway, for example, then we could add totally different information here, or probably we would not use the mapping at all, but just from the model, let us generate a stub for a gateway, and then have our totally custom implementation, which is, I think, the default, kind of the default use case, Kevin, you use, or?
So this is basically what you're doing here. You're adding the implementation-specific data to your model using this mapping. Yeah.
So this here describes then the mapping, and we go back now to the model. And so what we will use is the endpoint to retrieve the mapped model, which contains the PLC4X information. And the other thing we will consume is then the Ditto plugin to get the Ditto representation of this virtual machine here. These are the two endpoints from the Vorto repository that we will use now in the example. Then we will use the PLC4X information. We will extract the information and use it to start reading values from the PLC and send it over to Ditto. So now, once again, change the window to my IDE. The code is, as said initially, the code is on GitHub, and it's reasonably cleaned up. So everybody is invited to have a look here. And we also tried, or also working on making it as
But it's very hard.
Oh yeah, of course. So can you read it now? Okay, excellent. So for example, we added the parser for command line parameters to make it more adjustable, so to say. Okay, so I mean, first thing that happened is just reading some command line parameters, and command line parameters are the namespace, the name of the model version, the model mapping, Ditto endpoint, twin ID, the thing we'll have in Ditto, those things. So the first thing we do is then we use a generate point. Kevin, probably you may comment on that endpoint.
Just using the plugin. So what you're addressing here is the Eclipse Ditto plugin, and then you refer to the model that's being inserted into that string on the right side, and the target thing JSON just specifies that you want to generate the ditto thing JSON and not the schema, the JSON schema, which is the second option that this Eclipse Ditto plugin offers.
Exactly, and this is the JSON representation that Ditto expects. So we will use exactly this Ditto a JSON string in the next step, basically to create the thing in Ditto if it does not already exist. So yeah, this is something we see down here then. So you see here the variable Ditto JSON string, and if we go down here, then you see we assemble a put call for the Ditto endpoint, for the things endpoint, and create send the Ditto JSON as payload, which effectively creates the thing if it does not exist, or overrides always if it already exists. In this example, if no thing ID is given as command line, then just a random thing ID is generated. So this is the first thing. Then we may have the thing in Ditto, but yeah, no values in it. So the next endpoint we use is this endpoint here, which is dependent on the namespace, model name, model version, and the model mapping. So Kevin, you can say probably a bit more about that.
Metadata, and if you apply the name of the mapping or the target platform that you specified within the mapping, then you will not only retrieve the content of your actual Vorto model, but you will get the Vorto model with the enriched specific data that you have specified in your model mapping. That's why you add it in as the last parameter to the URL. Okay, so from this endpoint, we get a pretty big JSON representation, mapping JSON, where we then can extract the parameters from. This is, if we go down here, so probably following the program flow a bit, what we do also initially is set up the configuration to our Ditto instance via the Ditto client to send later on the device updates there. Here, so here's the device created, and here we really start off. So here we are taking this mapping JSON that we get and read out the important configuration properties. So this is the data of the model enriched with the attributes that PLC4X will need later on. They are then, yeah, that's just JSON wrangling basically. We'll read out the name of the property again and the type of the property, which is double, Boolean, or integer in our case. And we'll read the mapping attributes, which are address, rate, and URL, as you have seen. And these three we then can use to just initiate a PLC4X request. So basically, I use a very simple implementation here. I have a scheduled executor who executes with the given rate, just builds up a connection, reads the value, and closes the connection. And if the response it gets is not okay, it will print a warning, and if it's okay, it will send the value to Ditto. This is then the final building block of our solution. Basically, all we do here is basically use the Ditto client project to fetch the value depending on which type the Vorto model gives it, and send it then as a feature update to Ditto. Yeah, as said, this is a quite complex piece of code in the end, although the functionality is pretty simple. And now I just start it for a moment, and we will have a look
we try to make the output as good as possible. So you see the default values we start with really point to the model we just discussed. And the Ditto endpoint is a Ditto instance we run. And the twin ID is randomly generated. And the namespace is org apache psfrx.example. So it takes the same namespace as the Vorto model has, although this is not necessary. So if we look in our twin in Ditto, then we should see a twin created with this name, which has the properties given by the Vorto model. Configuration is as given from the mapping. So we have everything we need to build up a PLC connection, and then you see there are frequently updates sent. Some requests fail. This may be for two reasons. First one, it's pretty inefficient to build up a new connection for each request, sometimes even in parallel. And second thing is latency may be high because I'm using VPN and I'm in another part of Germany right now. So what I want to show you now is I use this Ditto ID and change my window to the browser again to go to the Ditto instance, and here I will query the device now with the get endpoint, which just retrieves the device. And I execute it and make it a bit bigger, probably. I hope you can see it well now. So this is the current state of our device. And if I re-execute the command, then it should change. Okay, you see, position is now 4,000, and if I execute again, it's 4,500, and now it's 5,000 and some. So what you see here are is that the whole setup works. What you also see is that there's some kind of integration between Ditto and Vorto. There is this definition tag, which takes a string which is exactly in the format of a Vorto definition. So in fact, someone who only looks at this Ditto instance could see, okay, it's a Vorto definition, and I will look it up. Can now look it up basically and learn a bit more about those values in here. And what you also see is that it's the information as we have information about the types, for example, that availability is a Boolean. As we have this information, we can cast the types appropriately and know that this availability here is in fact true or false and not 1 or 0 as it was with the last implementation. So this is basically what we wanted to show you in this example. And the really nice thing now is that if somebody else would implement now the same virtual machine with this position, render, motor, current, process state, availability somewhere else, then we would just create a different mapping. And he could just start the gateway with the other mapping, and we would provide basically a twin for the same model. So someone who consumes the data, for example, we prepared something for you here, which is a virtual digital twin who just uses the position field. So as long takes some time to render. So if we don't care from the consumer side of things, we don't care about where you get this position value from, as long as it's semantically equivalent. As it semantically has the right content that we need for our application. While this thing here loads, it will be loaded at some point in time, but the model is quite big. Yeah, so while this thing still loads, I think we can start with a little discussion. So are there any questions so far? Okay, there are no questions yet, but the model has loaded, so we can have a look here. What you see here is that there's some kind of stance which moves. The coordinates for the movement here come from Dito, which gets them from the PLC according to the model from Vorto. So this thing here only has to know, okay, there's this field position which has a decimal value. So this thing here only knows about the model, not about the mapping. And this is a setup where you see why this makes sense, especially if you have high volume products. Of course, it doesn't make sense if you have a single machine. But if you think about the typical twins, the typical things Bosch thinks about, also that Kai presented last week, like smaller devices, consumer products, then you may have hundreds of thousands of those. But for all those clocks, you don't care how they calculate the time or how they store the time, but they just have an attribute time, probably, on accuracy or something. Yeah. So are there any questions so far to this whole Vorto thing we covered today, or to this specific example we showed? Let me bring this here back. So this webinar really is not that much about the exact code we have shown, but more about the concept. No questions?
If you're interested in learning more about Vorto, then you can just get in touch with us on our GitHub channel, or just open an issue on GitHub. We're very happy to help you to get more familiar with Vorto and how to fit it maybe into your use case.
Yes, exactly. Yeah, I mean, if there are no questions, we can just basically leave it as is. It really is worth thinking about it a bit, because this Vorto specification, especially with this plugin mechanism, can be used to generate everything out of it. So if you say, okay, that's nice as Waterline, but I need something in a totally different language, that's basically the concept of Vorto. Then you just create a plugin, but you already have some standardized way on how to describe the model and how to store it and version it, but can totally generate your own XML or whatever you'd like to. In fact, we could even go there and generate from a model. We could generate Java code, which is all fix stuff. We could just generate this code with a plugin and download it to compile it. Go that far to generate C code, which would be just generate the right data structure. So this is really the concept of Vorto. Is, I would say, from my perception, it's not so much that we have this specification, this is the only right way to describe a thing, but it's more about, okay, this is a representation to describe the thing, and these are the plugins to translate between all the possible representations, and representations which are nearer towards usage, like a code stub. So if there are no more questions, then thanks all of you for your attention. Thank you, Kevin, for not only for participating today, but also for all the work you spent with me developing this example. And in fact, developing the example helped me to understand a lot about Vorto. And as Kevin said, if there are questions, just join the GitHub channel. all code shown here, and both presentations will be uploaded as usual on our website, pragmaticindustries.de/webinars. Yeah, and the last webinar we have scheduled in this series will be next week, and will be about Eclipse Hawkbit, which is a tool for, I would say, rollout management. We call it update over-the-air management, as this is the fancy wording from Tesla. But in the end, it's really about managing rollouts of updates for probably billions of devices. So thanks all of you for attending once again, and have a nice day today. Goodbye from my side.